Next up is Simon Hoyle, the managing director of Ventuer, and he will talk about what he calls the biggest hole in the facade.
Well, good morning all. It's great to be here and great to see so many familiar faces. So as Simon said, I'm Simon Hoyle. I'm here today with Ventuer, and the subject of my chat is performance louvers and what can be engineering the largest hole in your building envelope. If you haven't worked with Ventuer in the past, we provide a full range of performance louvers, weather-resistant acoustic and smoke relief vents. We've got 3 branches. We have our factory down in Invercargill, our head office and technical support team here in Auckland, and recently opened a branch in Melbourne. We get involved in a lot of different projects, but they can be mostly categorised into one of 3 categories. We do a lot of commercial work, we do a lot of industrial, factories, warehouses and agricultural, and we're starting to do an increasing amount of infrastructure, which includes data centres, railway stations, water treatment plants and the like. The previous speaker has already touched on this project. Ventuer is very proud to be part of the Tikaha 1 New Zealand Stadium in Christchurch. We're providing over 3,000 square metres of acoustic, operable and fixed blade weather louvers for this project. This video clip was shot about a month ago, shows the facade install. These louvers in the centre here, some of our operable louvers, just to give you an idea of the scale, these are over 5 metre tall panels, 1.5 metre wide, with coloured blades that match in with the cultural narrative of the adjacent facade. At Ventuer, we take our social and environmental responsibilities very seriously, and we've made a commitment that we'll plant a tree for every square metre of our product that gets installed on a building. To this end, we've partnered with an organisation called Tree Nation, who facilitates tree planting and reforestation projects globally. That's enough of a preamble. There's 3 things I want to talk about today. One is performance louvers and how they can be the largest, leakiest and noisiest opening in your facade. I want to talk about product certification and the fact that independently tested systems provide reliable results. And lastly, I want to talk a little bit about louver installation. I want to start by going back 100 years and looking at window detailing. So 100 years ago, we were building buildings like this, and we were doing windows like this. The building designer of the day acknowledged significant risks when it came to his windows. They were single glazed, thermal performance, acoustic performance was non-existent, and there was always that ever-present risk of water ingress around that timber joinery. If we fast forward 100 years, those risks, as they relate to windows, have been significantly mitigated. Sure, we've just heard from Thermosash and Mott's around thermal performance. The problem hasn't gone away, but the products have increased in performance substantially. The challenges for us, have louvers kept up? Well, time hasn't stood still. We're no longer making louvers out of timber slats. We do have some great products out there, but when you consider that a fixed blade aluminium louver is still essentially a chunk of aluminium full of holes, you start to appreciate the risk that's associated. There's no such thing as a thermally broken louver. There's no such thing as an acoustic louver that has the attenuation performance of a curtain wall or a solid block wall. And there's no such thing, despite some claims that are out there, of a fixed blade louver that's 100% watertight 100% of the time. Now, sometimes it doesn't matter. If we're building a public toilet, thermal performance, acoustic performance, even rain defence performance for the louvers is not really a big deal. But we're not all building public toilets. Some of these projects we can get involved in, the risk is substantially higher. The Christchurch Stadium, as I said, 3,200 square metres of louver on that facade. The home ground, the Auckland City Mission, with very large acoustic louvers feeding the mechanical plant rooms. Hilton Foods, a food processing plant out in Wirri in South Auckland, huge amount of louvers on that facade. If we get these wrong, if the water ingress through these louvers is higher than expected, if the thermal performance, the acoustic performance isn't designed correctly, that's opening up the building designer, the contractor, the supplier, and ultimately the builder owner to substantial risk. So how do we mitigate this risk? The first thing to do is to work with a tested product. And if you're responsible for selecting louvers or procuring louvers, I just ask you to do 3 things. The first is make sure the louver you're working with has been tested and certified. The second is make sure you've got access to that test report. And thirdly, understand what that test report's telling you. This photo here is the Bisria test facility up in the United Kingdom, where all of our louvers have been tested. And we test to the BSE in 13030 standard. And that test gives us two key bits of data. One is rain defence, the second is aerodynamic or airflow performance. This audience is going to be mostly interested in rain defence. There's four classifications, Class A, B, C, D. Class A louver under the test conditions allows less than 1% of the water in. The opposite end of the scale, a Class D louver, allows greater than 20% of the rain to enter between the blades and inside the building. I'm going to diverge slightly and talk about purchasing a car in 1976 in communist Germany. Now, if you're on the wrong side of the Berlin Wall and you're in the market for a car, the likely thing you were looking at was this Trabant 601. Now, those of you out there that don't know what the Trabant was, its body was made out of a cardboard-like material. It had an unreliable and underpowered two-stroke engine, and it had a maximum speed of 100 k's an hour. And yet the East Germans fell over themselves to buy this thing. They'd go on a 10 to 15-year waiting list just to get their hands on one, and they'd put down 3 or 4 years' annual salary to buy one. When you consider that on the other side of the Berlin Wall, the population had access to something like this BMW, you wonder why the East Germans were happy with such an inferior product. Well, John's already used the term, but they didn't know what good looked like. Most of them had never seen a BMW in the flesh, let alone driven one. They didn't understand what quality, what handling, what power looked like in a good car. And the same context can be applied to louvers today. Do you know what good looks like when it comes to a louver system? There's 3 suppliers of double bank drainable weather louvers here in New Zealand, 3 main suppliers, and there's ourselves and 2 others. We've taken the technical literature, publicly available technical literature for all 3 systems and overlaid them to compare performance results. This slide shows the rain defence performance. Along the bottom is airflow in through the louver, down the side is percentage of effectiveness for wind-driven rain. The blue line at the top is the Ventuer product, it's the VL2SD system. Green line is alternative number 1, and orange is alternative number 2. Now, it's worth bearing in mind that these 3 products look very similar. If they're up on a building 2 stories up, you're pretty hard pressed to tell the difference between them. They're all tested, they're all certified, there's test reports available. Does it mean they perform the same way? No. When you look at this clicker would work, when there's no air entering the louver, they're all providing about 100% rain defence. Go back to the Trabant example. When the Trabant and the BMW are standing still, they're doing pretty much the same job. When we start bringing air in through the louver, you start to see that performance change. At the end of the test, at 3.5 metres a second intake velocity, the Ventuer product's still holding 95% effectiveness. The green products drop down to 80% effectiveness, and the orange product is down below 20%. That means over 80% of the water is getting in between the blades of that system. Same 3 products just plotted for airflow. Again, we can see a similar performance correlation. So, do you understand what good looks like, or are you just using the same product as you used last time because you haven't gone out and looked? We understand that working with all this data can be a bit mind-boggling, particularly if you're not using it, working with it all the time. We've created this tool on our website, which is a louver selector tool. You just simply answer some multi-choice questions. Depending on the answers you give, it'll ask different questions till eventually it will prescribe the right product for your application. Conscious there's going to be other presentations about carbon later in the day. However, operational carbon emissions as they relate to louver performance is something that I'm very precious about. And we've modelled a building that would use 75 cubic metres per second of airflow, operational 10 hours a day over a 25-year lifespan. If we look at 3 different louver scenarios, a high efficiency louver, medium efficiency and low efficiency louver across that design lifespan, we can see the operational carbon emissions for each choice. For a high efficiency louver, or a louver that's averaging 10 pascals of pressure loss, we're seeing about 13 tonnes of carbon being emitted. The other end of the scale, that low efficiency louver, we're over 35 tonnes. And just to put some context around it, these little aeroplanes here mimic the carbon emissions created by an economy seat from Auckland to Heathrow. We can see that by simply choosing the right louver, or sizing it correctly, over 25 years, we could save the equivalent of 9 flights halfway around the world. And then there's, of course, embodied carbon. So if we take a product like a 3-stage louver, which is quite aluminium heavy, and it's made out of black aluminium, it could contain up to nearly half a tonne of embodied carbon. If we're using green aluminium from TY Point, it could be as low as 60 kgs per square metre. It's worth asking where your aluminium's coming from. The last thing I want to touch on was installation. Now, we've all seen horror stories, everybody's got horror stories, I want to share a couple. Here's a situation where a contractor has ordered louvers off a mechanical schedule without site measuring the openings in the facade. Gets to site, the louvers are too small for the hole, so the solution has been to glue a piece of 3mm sheet to the wall, cut a hole in it and then install his louver. On the inside it got even better. These louvers have got intumescent fire dampers behind them. The intumescent fire dampers have been ordered at the wrong size, and a solution here was to take leftover fire dampers, cut them up on site, stick them together and make these little infill panels. This is another example where a contractor has made electro-galv sheet metal plenums to go into window joinery prior to the louvers being installed. So this is electro-galv, not aluminium. It's been sealed up with duct mastic, so not facade sealant. This is the goop they use on ventilation ducts, and he's screwed it into place with galvanised Tek screws. I don't think I need to tell this audience what's going wrong there. So why do these problems occur? Well, there's two recurring themes. One is people reinventing the wheel when it comes to louver installation details. We get it, people don't, there's trades out there that don't work with louvers every day of the week like we do. And if they're reinventing installation details, they're not always reinventing them well. The second is the wrong sub-trade being asked to install the louvers. All too often we see the main contractors awarding ventilation louvers to mechanical subcontractors because they associate them with the HVAC system. Now these guys don't belong on the facade. They do a fantastic job inside, seismic, ductwork, refrigerant, the works. They don't understand facade engineering or weather tightness details. It's worth noting all of these examples I've just showed you were mechanical engineers. So what's the answer? Well, I lifted this cartoon, great cartoon by Malcolm Walker. It's going to be a while before artificial intelligence helps us out of this one. Today at ZAK, we're launching a new louver system which we believe answers a bunch of these questions. So we've taken the perimeter framing for all of our louvers and developed alternative systems that allows any of our louver systems to be glazed into a window joinery suite as if they were a pane of glass. This photo here is a photo of a sample that's out on the table out in the foyer. If you haven't seen it already, drop by on the break and let's take a look at it. But it does two things. So here's some more sectional details. This is a 2-stage louver. Going into curtain wall, our single bank drainable louver, again glazed in, a slimline louver going into a residential suite, and then our ventilation cowl, so not a louver but a cowl, again with that proprietary glazed in frame around, enabling it to be inserted into the window suitably. Now this does two things. One is it deals with the whole detailing question. There are thousands of people in the industry in New Zealand that understand glazing. There are those same thousands of people understand window detailing. They know what a good window detail looks like on paper, and they know what a good window installation detail looks on site. We're not reinventing the wheel. The second is it encourages the builders to put the louvers in the right contract package. When the louvers are installed, are shown as being into the window joinery, there's not the temptation for them to award them to an HVAC contractor. They're going to put them in the window joiner's contract package where they belong. So just to recap, performance louvers, the risks around leaks, drafts and noise can be engineered out. Make sure you're using proper test data. Facts and data will set you free. And lastly, installation, the right detail and the right contractor will end in the right result. Thank you very much.